Alright, now let's look at this question, which will tackle the question related to probability distribution. So this is somewhat testable concept on mathematics. If you're into like the mathematics probability you have read, then this should be familiar to you, the distributions. Option E is Poisson distribution. Poisson distribution is suitable for modeling the number of discrete events occurring within a fixed time interval. Let's keep it. If you want the PDF version including the keyword tricks, please enroll in Diamond membership or above by clicking the join button. Please select the Diamond tab there, then proceed with it. And after you're done enrolling in membership, please do connect with me on LinkedIn at the rate of Cloud Guru Amit or Instagram at the rate of Amit Physique. I'll be happy to help you with the hands-on files as well as the PDF files. We'll move to B. B says uniform distribution. Uniform assumes equal probability across a range which doesn't reflect event frequency over time. Incorrect. We'll move to C. C says normal distribution. Normal distribution is continuous and symmetric, not perfect for modeling discrete event counts. Wrong answer. We'll move to option D. D says binomial distribution. Binomial requires fixed trials and success probability, which doesn't apply to unbounded event arrivals. Wrong answer. We'll lock option A, Poisson distribution, as the right answer. Okay, now let's look at this question. We'll first look at option A. It says apply one hot encoding to transform categorical variables into binary columns, including those with high correlation. One hot encoding is used for categorical variables, not for resolving correlation among numerical features. Wrong answer. We'll move to now option B. B says use matrix multiplication to combine correlated features into new composite variables. Matrix multiplication doesn't reduce dimensionality or address feature redundancy. Wrong answer. You'll move to option C. C says generate a new feature space using principal component analysis (PCA) to reduce dimensionality and remove correlation. PCA, that is principal component analysis, PCA transforms correlated features into uncorrelated principal components, reducing dimensionality and improving model stability. Let's keep it. We'll move to D. D says calculate the Pearson correlation coefficient to measure linear relationship between features. Pearson correlation quantifies relationships but doesn't transform or reduce the feature space. We'll delete this. We'll lock option C as the right answer. Let's bring the heat to the snow. We'll look at option A first. Option A, if we focus, lambda adds unnecessary complexity for logging when CloudTrail already handles it natively. Incorrect. Now let's move to option B. B, if we look, CloudTrail natively logs API activity to S3 without custom code, and CloudWatch with SNS handles metric based alerts efficiently. Let's keep this. We'll move to now option C. Again, option C uses lambda just like option A, which we have rejected. CloudTrail doesn't accept logs from lambda. It passively records AWS API activity. Let's delete this. We'll now move to option D. Option D, if we look, SNS alone doesn't detect overfitting. A CloudWatch metric and alarm are required. Wrong answer. We'll lock option B as the correct choice. Alright, now let's look at this question. We'll look at option A. It says increase the learning rate to help the optimizer escape a local minimum during training. Increasing a learning rate affects convergence speed but doesn't reduce overfitting. We'll reject it. We'll move to option B. B says raise the dropout rate at the flatten layer to improve the model's generalization capability. Increasing dropout reduces overfitting by preventing co-adaptation of neurons. Let's keep it. We'll now move to option C. C says expand the size of the dense layer following the flattened layer to increase model complexity. Adding complexity worsens overfitting by fitting noise in training data. Wrong answer. We'll move to option D. D says train the model for more epochs to allow the optimizer to reach a better minimum. More epochs deepen overfitting rather than improving generalization. We'll delete this and lock option B as the right answer. Alrighty, this is a multiple choice question. We need to select two correct answers. Option A says modify the built-in image classification algorithm to integrate the inception network and use it for training. Built-in algorithms are not designed for architecture level modification. Incorrect. We'll move to B. Option B, if you look, submit a support case to the SageMaker team asking for a change in the default architecture to inception. Support cases doesn't or don't modify default algorithms or enable architecture changes. Well rejected. We'll move to C. Option C says package a Docker container with TensorFlow estimator configured to use inception and run training in SageMaker. Docker container with TensorFlow estimator allow full control over model architecture and training logic. Let's park it. We'll move to option D. D says write custom code using TensorFlow estimator to load inception model and train it in SageMaker. TensorFlow estimator with custom code allows direct implementation of inception architecture within SageMaker. Looks good. We'll lock option C and D as the right answers. Alright, now let's look at this question. Option A, if we look, using Glue, Kinesis Services, Amazon, ES and EMR enables support for real-time clickstream and batch analysis while maintaining cataloging and recommendation capabilities. Let's keep this. Option B, if you look, Athena is a query engine, not a data catalog. AWS Glue is better suited for metadata management. So this option is incorrect. Let's move to option C. Option C, if you look, Kinesis data analytics is designed for streaming, not historical data analysis. So this statement is incorrect. We'll reject it. We'll move to option D. Option D, if you look here, DynamoDB streams are not ideal or perfect for capturing a web scale clickstream data. What requirement we have? So option D is wrong. We'll lock option E as the right answer. Alright, now let's look at this question. This is all about strategy and model predictive accuracy. Option E says fully rebuilt the model architecture to accommodate dynamic inventory shifts. Rebuilding the model architecture is unnecessary unless concept drift invalidates the original model structure. Incorrect. Let's move to option B. B says periodically adjust the model's hyperparameters to reduce performance degradation. Hyperparameter tuning doesn't resolve data drift or outdated training inputs. We'll eliminate it. Move to option C. Option C says retrain the model from scratch using the original dataset and add a regularization term to account for inventory changes. Regularization controls overfitting but fails to capture new trends or inventory shifts present in recent data. Wrong answer. We'll move to now option D. D says retrain the model using the original training data combined with recent data that reflects current inventory updates. Original training data combined with recent data incorporates recent patterns and mitigates model drift by aligning training data with current conditions. We'll lock option D as the right answer. Alrighty, now let's look at this question. Option E says save training datasets as objects in S3 and query them using services like Amazon Athena. Amazon S3 offers elastic storage, low cost, and integrates with SQL engines like Athena for querying without provisioning infrastructure. Let's keep it. We'll move to B. B says store training datasets as files on EBS volumes mounted on EC2 instance. EBS volumes require manual scaling and incurs compute cost even when idle. So let's delete this. We'll move to now C. C says load training datasets into structured tables in a multi-node Redshift cluster. A Redshift offers SQL querying but incurs higher cost. We need a cost-effective solution, right? And complexity will also increase if we use Redshift. So as mentioned in previous steps by me, that whenever you see cost-effective or solutions which require low maintenance, low development effort or maintenance overhead, then Redshift, EMR, those are not the right answers. So on the basis of that, we can reject this as well. Now let's move to option D. D says insert training datasets into global tables in DynamoDB for distributed access. DynamoDB is optimized for key value access, not for SQL based exploration of training datasets. We'll eliminate it. We'll lock option A as the right answer. Alright, now this is a multiple choice question. We need to select two correct answers. Option A says increase the depth and number of decision trees in the random forest to capture more feature interactions. Adding deep trees increases complexity and worsens overfitting without addressing imbalance. Incorrect. Now let's move to option B. B says add test samples into the training set to expose the model to unseen patterns. Including test data in training compromises model evolution and inflates performance metrics. We'll reject it. We'll move to option C. C says create synthetic positive samples by duplicating existing ones and injecting small noise into the duplicates. Synthetic duplication with noise helps balance the dataset and improve minority class learning. Let's keep it. We'll move to D. D says adjust the cost function to penalize false negatives more heavily than false positive. Adjusting the cost function prioritizes cost identification, prioritizes correct identification of rare positive cases. So that being said, this again looks good. We'll lock option C and D as the right answers. Alrighty, this is an easy question, I'll say, because if you're into data engineering or have used Athena, then you might be already knowing the correct answer. Option A says CSV files. CSV is row based and inefficient for columnar queries at scale. Incorrect. We'll move to B. B says Parquet files. Parquet is a columnar format which reduces scan time and improves query efficiency in Athena by reading only relevant columns. Let's keep this. We'll move to C. C says compressed JSON. Compressed JSON lacks schema enforcement and slows down parsing during querying. Incorrect. We'll move to now option D. D says record IO. Record IO is optimized for training pipelines, not for analytical querying with Athena. Wrong answer. If we look at the official documentation of the blog, it says here are the query performance tips when using Athena. So point number 5 says Apache Parquet or ORC are popular file formats for analytic workloads. They are often described as a columnar file formats because they store data not by row but by column. They also have features that allow query engines to reduce the amount of data that needs to be loaded in different ways. Looks good? We'll lock option B, Parquet files, as the right answer. So please don't go away. Let's meet in the next part of this series. If you want the PDF version including the keyword tricks, please enroll in Diamond membership or above by clicking the join button. Please select the Diamond tab there. then proceed with it. And after you're done enrolling in membership, please do connect with me on LinkedIn at the rate of Cloud Guru Amit, or Instagram at the rate of Amit Physique. I'll be happy to help you with the hands-on files as well as the PDF files.